Welcome to G Math tutorial. Now consider the next example, that is question 2c. The question is, a telegraph wire hangs in the form of a curve y is equal to a log of sec x upon a, where a is constant. Then show that radius of curvature at any point is a into sec x upon a. We want to show this. That is, radius of curvature is a into sec x upon a. Solution: given y is equal to a log of sec of x upon a. Now by differentiating with respect to x, we get dy by dx is a into 1 upon sec x upon a, sec x upon a into tan x upon a into 1 upon a. Then dy by dx is, by deleting the numerator and denominator terms, we get tan x upon a. This is first derivative. Now we find second derivative, that is d square y by dx square. d square y by dx square is equal to sec square x upon a into 1 upon a. This is second derivative. Then we have the formula for radius of curvature is rho is equal to 1 plus dy by dx square raised to 3 by 2 divided by d square y by dx square. Then by above first derivative and second derivative put in the formula, then the rho is equal to 1 plus tan square x upon a bracket raised to 3 by 2 divided by sec square x upon a into 1 upon a, and it is equal to, as 1 plus tan square theta is sec square theta, we get sec square x upon a. By deleting sec square raised to 3 by 2, it becomes sec a into sec x upon a. This is remaining. So the rho a into sec x upon a, this is the required radius of curvature. Thank you for watching.